Welcome to our cosmic safari, explorers. Today we're setting our telescopes on the most massive planets in the known universe, worlds so large they make Jupiter look like a marble. We're talking about gas behemoths that could swallow our entire solar system and theoretical titans that stretch the very definition of a planet. Get ready to have your mind blown wide open as we dive into the largest known planets ever discovered, what makes them tick, and how they stack up against the gas giants in our own cosmic backyard. Buckle up, space cadets, it's going to be a wild ride. First up is HD 100546b, a planet so young it's practically still baking in the cosmic oven. Located about 620 light-years away in the constellation Musca, this behemoth is still swaddled in the protoplanetary disk of gas and dust surrounding its parent star. This cosmic construction site gives us a front-row seat to the awe-inspiring process of planetary formation. Imagine a swirling vortex of gas and dust, a cosmic maelstrom where gravity reigns supreme. As this material collides and clumps together, it begins to coalesce, forming a dense core. That's what we're witnessing with HD 100546b, a giant planet in its infancy, still accreting material and sculpting its surroundings. This celestial newborn is estimated to be up to 6.9 times the radius of Jupiter. Observations suggest that HD 100546b may also be surrounded by a massive ring system. Studying HD 100546b gives us a glimpse into the chaotic process that birthed our own solar system billions of years ago. Now let's journey to the constellation Ophiuchus, about 450 light-years away, where we encounter Rox's 42b, a planet that's basically a cosmic toddler still figuring out how to planet. And let me tell you, this toddler is having a growth spurt for the ages. With a radius about 2.5 times that of Jupiter, Rox's 42b is what astronomers call a super Jupiter, a planet so large it makes our own gas giant look downright puny. But here's the thing about Rox's 42b. It's not just big, it's also incredibly puffy. Like a cosmic marshmallow, this planet has a surprisingly low density, indicating that it's still retaining a significant amount of heat from its formation. You see, planets, like stars, are born hot. They form from the gravitational collapse of massive clouds of gas and dust, and as this material falls inward, it heats up due to friction and compression. This heat causes the planet to expand like a hot air balloon, making it less dense than it would be otherwise. In the case of Rox's 42b, this heat is lingering longer than usual because the planet is still relatively young, only a few million years old. That's practically a blink of an eye in cosmic terms. Over time, Rox's 42b will cool down and contract, its puffy atmosphere gradually settling into a more compact form. But for now it remains a fascinating example of how planets evolve and change in their early years. And speaking of change, Rox's 42b's orbit is another intriguing aspect of this planetary toddler. Unlike most planets which orbit their stars in relatively circular paths, Rox's 42b follows a highly eccentric orbit, meaning it swings in close to its star and then back out again, like a cosmic pendulum. This unusual orbit suggests that Rox's 42b may have had a rather chaotic upbringing, perhaps experiencing gravitational interactions with other planets in its system that nudged it into its current path. Hold on to your hats, cosmic explorers, because our next stop takes us to the constellation Scorpius, about 1,000 light-years away, where we encounter WASP 17b, a planet that's breaking all the rules. This gas giant is about twice the radius of Jupiter, making it another member of the Super Jupiter Club. But unlike Rox's 42b, WASP 17b isn't puffy. In fact, it's quite the opposite. With a mass only about half that of Jupiter, WASP 17b is one of the least dense planets ever discovered. Imagine a planet so light and airy that it could practically float on water. That's WASP 17b. But what's even more bizarre about this celestial oddball is its orbit. You see, WASP 17b orbits its star in the opposite direction of the star's rotation. That's right, folks, this planet is going against the grain. Now you might be wondering, Neil, how is that even possible? Well, the prevailing theory is that WASP 17b didn't form where it is now. Instead, it likely formed farther out in its star system and was later nudged inward, perhaps by a gravitational interaction with another massive object. This close encounter could have flipped the planet's orbit, sending it on its current retrograde path. But that's not the only strange thing about WASP-17b's orbit. This planet also whips around its star at a breakneck pace, completing one orbit in just 3.7 Earth days. That's right folks, a year on WASP-17b is shorter than a week on Earth. This incredibly short orbital period means that WASP-17b is tidally locked to its star, with one side always facing the searing heat and the other perpetually shrouded in darkness. So there you have it, WASP-17b, a planet that's both incredibly large and incredibly strange, defying our expectations and reminding us that the universe is full of surprises. Get ready to have your minds boggled, my fellow space enthusiasts, because our next destination is TRES-4b, a planet so bizarre, it makes WASP-17b look downright ordinary. Located about 1,400 light-years away in the constellation Hercules, TRES-4b is a gas giant with a radius about 1.8 times that of Jupiter, making it another member of the Super Jupiter Club. But what sets TRES-4b apart from the pack is its density, or rather, its lack thereof. This planet is so incredibly puffy, so mind-bogglingly light and airy, that it has a density less than that of cork. That's right folks, you could practically build a raft out of this planet. To put that in perspective, TRES-4b is about as dense as a marshmallow. Imagine holding a marshmallow in your hand that's larger than Jupiter. That's how mind-bogglingly strange this planet is. Now you might be wondering, Neil, how can a planet be so incredibly fluffy? Well, astronomers believe that TRES-4b's extreme puffiness is due to its proximity to its star. You see, this planet orbits its star at a distance of just 0.05 astronomical units, which is about 20 times closer than Earth is to the Sun. At such a close distance, TRES-4b is bombarded by an intense amount of radiation from its star, heating its atmosphere to a scorching 1,300 degrees Celsius, 2,400 degrees Fahrenheit. This intense heat causes the planet's atmosphere to expand outward like a hot air balloon, making it far less dense than it would be otherwise. But TRES-4b's extreme puffiness comes at a cost. The planet's atmosphere is so loosely bound that it's constantly escaping into space, forming a giant comet-like tail that trails behind the planet. This atmospheric escape is slowly but surely shrinking TRES-4b, and astronomers estimate that the planet could lose a significant portion of its mass over the next billion years. Prepare yourselves, fellow cosmic explorers, because our final destination takes us to the realm where planets blur the lines between themselves and stars. I'm talking about Dennis PJ082303, 1491201b, or as I like to call it, Dennis for short, a massive object located about 67 light-years away in the constellation Vela. Now Dennis is a real enigma, a celestial trickster that has astronomers scratching their heads. You see, Dennis has a mass about 28.5 times that of Jupiter, putting it squarely in the realm of brown dwarfs. Brown dwarfs are often called failed stars because they're not massive enough to sustain nuclear fusion in their cores, the process that makes stars shine. But here's the thing about Dennis: despite its enormous mass, it has a radius that's only slightly larger than Jupiter's. That's incredibly small for an object as massive as Dennis, and it suggests that this cosmic heavyweight is incredibly dense, far denser than any planet we've encountered so far. So, what exactly is Dennis? Is it a super Jupiter on steroids, a planet that's been squeezed and compressed to its absolute limit? Or is it a brown dwarf that somehow managed to shrink itself down to a fraction of its expected size? The truth is, astronomers aren't entirely sure. Dennis challenges our very definition of what it means to be a planet, blurring the lines between these celestial objects and their stellar counterparts. It's a reminder that the universe is full of strange and wonderful objects that defy our expectations, objects that force us to expand our understanding of the cosmos and our place within it. As we've seen, the universe's largest planets are more than just giant balls of gas. They're diverse, extreme, and often downright bizarre worlds that challenge our understanding of what a planet can be. Some, like HD 100546b, offer us glimpses into the chaotic birth of planetary systems, while others, like Rox's 42BB, showcase the incredible diversity of planetary evolution. And then there are the rule breakers, the planets that defy our expectations and force us to rethink our place in the cosmic pecking order. Planets like WASP-17b with its backward orbit and TRES-4b, the Marshmallow Planet, remind us that the universe is full of surprises and that our journey of cosmic discovery is far from over. And as we continue to explore the cosmos with missions like TESS, JWST, and Plato, we're bound to find even larger, weirder, and more mind-boggling worlds. Who knows what other cosmic giants are lurking out there in the vast expanse of space, waiting to be discovered. Perhaps one day, we'll find a planet so large, so massive, that it makes even the most extreme objects we've discussed today seem like mere pebbles in comparison.